Hello and welcome to Saki Tech. So this video is about a series of network troubleshooting tools that you can use in command prompt to troubleshoot your network and get some information on your network. So in this video we're going to go over 4 commands: the IPCONFIG command, the NSLOOKUP command, the ping command, and the TRACERT, the trace route command. So let's start with IPCONFIG for now. Okay, so the first command that I want to go over is the IPCONFIG command. The IPCONFIG command is a very common and very useful tool. It displays the current information about your network. So it will give you basic information such as your IP address for the computer that you're stationed on. It will give you the IP address of your router. It will tell you where your DNS servers is, where your DHCP servers are. So let's type in the basic IPCONFIG command to start. And usually your local area connection is called the Ethernet adapter local area connection. So this is the connection where you plug in your network cable. The RJ45 network cable connects to the jack behind your computer, and this is the information pertaining to that connection. Anyway, you can get your IP address on this screen, which is 192.168.1.10. It's also called the IPv4 address. You can get your subnet mask right here, and you can get your default gateway address here. The default gateway is your router. So now I know the IP address for my router by looking at this screen. As you can see, you don't get much information about your local area connection here. So what I'll do is I'll clear the screen, type in CLS to clear the screen, and type in IPCONFIG/all to get more in-depth information about your local area connection. Press enter, and let's go back up to the Ethernet adapter local area connection. This time, as you can see, there's much more information present. The IP address is still here, the subnet mask is still here, the router address is still here, but this time you can also see where is your DHCP server. In my case, as you can tell, the IP address is the same as the router address. That means that my DHCP server is currently residing on the router. And then your DNS server, my DNS server, is also 192.168.1.1. It's the same as my router address. That means my DNS server is also on my router. So you can see how this tool is helpful in troubleshooting and information gathering. Information gathering is a part of troubleshooting. So, when it comes to networks, DNS, DHCP, the default gateway, the subnet mask, these are all important keywords, and you can get the information about these guys right here. So if you were trying to troubleshoot the DNS server, you can beforehand type in the IPCONFIG command and find where the DNS server is. So in my case, it's in the router. So I would go to the router settings to tweak the DNS server. Okay, so let's move on to the next command. This is all I want you to know about the IPCONFIG command. So clear the screen and let's get on. Okay, so one of the commands you'll be using a lot for network troubleshooting is the ping command. Ping command allows you to send a signal to another device, and if that device is active, it will send a response back to the sender. Now, for those of you who are interested in the details of how this works, the ping command is a subset of the ICMP, Internet Control Message Protocol, and it uses what is called an echo request. So when you ping a device, you send out an echo request, and if the device you pinged is active or online, you get an echo response. So already you can tell why this is a good command to troubleshoot. So for example, if your router is down and you try to ping it and you get no response, then you know that the router is what is giving you problems. So let's run this command a couple times and see what kind of results we get. So let us ping my router. Ping 192.168.1.1. Press enter, and we will analyze the printout here that we got. So what happens is we send out 4 packets to the destination, and the destination responds back with the same 4 packets. So as you can see here, 1, 2, 3, 4. So this is a reply from 192.168.1 and 1. That is my router. We sent out 32 bytes of data and we got back 32 bytes of data, and we got it back in less than 1 milliseconds. Down here you get a summary. So it says packets sent 4, packets received 4, packets lost 0. So that means this is a stable connection. And then there's some statistics here that is not important. So this is how the ping command works. It sends out an echo request using data packets of minuscule size, and then you get a response and you know that the other device is actually alive. So let us ping Google, www.google.com, and see what happens. So we got a similar printout. Let me just bring this to the top. And as you can see, this is the IP address of Google, and that is where we got the response from. As usual, we sent out 32 bytes of data. But as you can see, because Google is far, far, far away and not in my basement, it took 29 milliseconds to send, to get a response from Google. And if you look down here again, statistics are packets were sent 4, received 4, lost 0. So the connection was stable. Finally, let's ping a device that doesn't exist. This is going to yield the same kind of results if a device wasn't actually working. So if your router was down and you pinged your router, but you were not going to get a response from it. So let's see, ping 192.168.2.200. Press enter. So we're pinging it right now, and the request was timed out because that device does not exist. As you can see, the ping command is retrying. It's going to retry 4 times. The first packet didn't go through, second packet didn't go through, the third packet and the 4th packet did not go through. And as you can see at the summary, packets sent 4, received 0, and lost 4. So it was 100% lost. The signal does not exist. So if you ping a device, you get no response, and you lose all the packets, that means the system you're trying to reach is not connected to the network. It's having network problems. And this brings us to the end of the ping command. Let's clear the screen and move on to the next command. So the next command is the TRACERT command. So what the TRACERT command does is it lets you see step by step a route a packet takes to the destination that you specify. So if you send a packet to google.com, before the packet actually reaches google.com, it goes through a couple of routers to reach the destination. So it'll go to your router, then it will go to Verizon or Comcast router, and from there it's going to go to all kinds of different routers before it reaches Google servers. So you can also use the term hops instead of routers. So if it takes 10 routers to get to google.com, you can instead say it took 10 hops. So how do you use this command for troubleshooting? Let's actually run the command and see what kind of results we get. So I'm going to run the TRACERT command, and I'm gonna trace google.com. Okay. So as you can see, we're getting a list of each of the routers that we're hitting as we are closing in on google.com. And up here it will tell you what you're tracing, and it'll give you the IP address for Google. Okay, so the trace is complete. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We went through 11 hops, 11 routers before we actually reached google.com. Now if you look up top here, the first router that we actually hit was my own router. I can tell by the IP address right here, 192.168.1.1, and it's the wireless broadband router.home. The next one, because I have my service through Verizon, was Verizon's router. So it clearly goes step by step through all the hops. And then after 11 hops, we were at google.com. What is the significance of this? Let's say your home network was perfectly fine, but there was a problem with the Verizon routers. You can run the TRACERT command, and if there's any problems here, it will actually tell you what the problem is. It could say things like request timed out, destination unreachable, or it could also say that instead of 16 milliseconds, it could be saying like 5,000 milliseconds, just to give an example. And I don't think you'll ever see that. But so if the request times out, that means the problem lies with one of the routers that has to do with Verizon. And then you can call Verizon and you can tell them, hey, you guys are having a problem because I know that my router works because I ran the TRACERT command. So this is the idea behind the TRACERT command as far as troubleshooting goes. Okay, so that brings us to the end of this command. Let's clear the screen and move on to the final command. Okay, so the final command I want to talk about is the NSLOOKUP command. This command will fetch the DNS records for a given domain name or an IP address. Remember, the IP addresses and domain names are stored in DNS servers. So the NSLOOKUP command lets you query the DNS records to gather information. So let's say I wanted to know the IP address of google.com. I could simply type in NSLOOKUP and type in google.com, press enter, and let's analyze this printout. So the first two lines here show you which DNS server was used to get these results. My DNS server happens to reside on my router. As you can see, 192.168.1.1 is my router. So that is also my DNS server. And the answer that we got was this. All these IP addresses here are Google's IP addresses. Now Google is a huge website. Obviously it's not going to have one single IP address, and obviously the IP addresses will change from time to time. But if you type in any of these IP addresses in your browser, it will take you to google.com. So this is the basic idea behind the NSLOOKUP command. Okay, so this brings us to the end of this video. And if you guys liked the video, just click the like button. And if you like my videos, subscribe to my channel, because I will be updating more and more videos of this sort. And thank you for watching. Have a good day, guys.